Prioritizing advanced scheduling helps make sure sufficient workloads are assigned, which increases productivity and ensures critical work orders are completed first. In addition to the current day's workload, the supervisor should handle emergencies and reschedule assignments as needed. A set time for conducting processes reviews to assess what is working and what isn't. This is also the time to go over how processes can be improved. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 2 on maintenance and waste management, we will be discussing some more chapters on the maintenance and planning. So in the schedules and job priorities are important. So the weekly schedule and the priorities that help determine this schedule are essential to improve the productivity. So weekly scheduling frees up crew supervisors to focus on the current week without worrying about the backlog. So with the help of weekly schedules, we will be able to ensure that the productivity is increased. So maintenance and operations use the weekly schedule for coordinating the tasks in advance. So it is critical to properly determine the priority levels of new work orders to see if they should become part of the daily or weekly schedule. So with the help of these weekly schedules and daily schedules, we will be able to coordinate the work of the different departments in the organization. Prioritizing advanced scheduling helps make sure sufficient workloads are assigned, which increases productivity and ensures critical work orders are completed first. So when we are prioritizing the weekly schedule, it will help in assigning the work to the every employee, and also we can ensure that the critical work areas are taken care of. Then the next one is schedules based on projected highest skills available. Schedulers should select a week's worth of work from the planned backlog by using information on priority and job plan details. So what are the priority production to be undertaken and the job plan details? Based on that, the schedule should be prepared. They should then use a forecast of the maximum capabilities of the technician crew for the coming week. After several weeks have passed, technicians should have a better idea about the amount of work they are responsible for in a given week and become more productive. So when we have this kind of a plan, we will be able to assess what is the actual work which has been done in each of the production houses, and each of them can be more productive. Then schedule for every available work hour, bringing the previous principles together. This guideline details how much work to schedule. The scheduler should assign work plans for the technicians to complete a task during the following week for 100% of the forecasted hour. So for each technician, there should be a forecast of 100 hours. So if a crew has 800 labor hours available, the scheduler would give them 800 hours worth of work. Scheduling for 100% of the forecasted work hours prevents over and under scheduling. So when we know exactly the weekly schedule of each of the worker and we give them so many hours of work, we can ensure that the production gets finished on time. Then the daily work is handled by the crew leader. The crew leader should assign daily work to technicians based on skill level and work order requirements. In addition to the current day's workload, the supervisor should handle emergencies and reschedule assignments as needed. So it is almost always fluid thanks to the progress of the work being performed. This makes it difficult to schedule precise dot times very far in advance. Inaccuracy of individual time estimates and reactive maintenance are the two biggest factors contributing to this issue. So the daily scheduling is almost always fluid. That is, we cannot keep up with the daily scheduling. So we have to see that depending on the situation, the schedule can be changed. Then measure performance with schedule compliance. Scheduling success is measured by the adherence to 1 week schedule and its effectiveness. Wrench time is the ultimate measure of workforce efficiency and planning and scheduling effectiveness. So, with the help of this planning and scheduling, we will be able to ensure the efficiency of the workforce. Planning work before assigning it reduces unnecessary delays, while scheduled work reduces delays between the jobs. So, when you are planning work, you can see that there is no unnecessarily delays, and also when you are scheduling the work, we can reduce the delays between the jobs. Then implement maintenance planning and scheduling. So how do we implement maintenance planning and scheduling? So we have the various phases. In the phase 1, it is the setup phase. This phase encompasses all the steps needed to ensure your organization is on board with implementing maintenance planning and scheduling. So you should have made your case to leadership by exposing the hue of low productivity, explaining how planning and scheduling can help solve that issue, calculating the value of productivity improvement, and presenting the results in the form of return on investment. So, with the help of this setup, we should ensure that with the help of planning and scheduling, we have increased the productivity, as a result of which the return on investment also has increased. The second one is the define and analyze the situation. Now here it involves your team looking at your current situation and identifying problems currently faced in maintenance execution. During this phase, you should have representation from all levels of the maintenance process technicians, key managers or supervisors, and even representatives from procurement, finance and warehouse. This workshop-like environment should outline the current maintenance planning and the scheduling process. Next, in the phase 3, develop and prepare for delivery. Phase 3 involves planners and supervisors working to establish supporting documentation and process maps, as well as in defining in detail new processes, roles and responsibilities. Now, in this phase, we have to lay out the exact documentation of the work to be done in the production house. So, there will be the details of new processes, the roles and responsibilities of each of the worker will be mentioned clearly in this, and you should also make any necessary changes to your computerized maintenance management system, that is CMMS, and develop training and coaching programs. Conducting a single overview training session followed by a role specific training program is the most efficient way to go about the training. So this we can, with the help of this training sessions, we can prevent people from having to attend training sessions that does not pertain them. Then the next is the phase 4. So implement. Once everything is in its place, it's time to roll out the new maintenance planning and scheduling process. The goal here is to embed the new standards and procedures into daily routines of all those involved until they become the new norm. It's generally accepted to allow for a 3-month coaching period where individuals are assessed and receive help and close any gaps in performance. So, with the help of this, we will be able to set new standards and see that the employees work up to the standards. So, if you operate a shift system, 6 months should be sufficient. Remember, planners should only work on the processes, not in the processes. So, they should know what are the various processes, and they should see that the plan is for the actual carrying out of the process itself. Next one is the review. So it is also called as the closeout. It is what is going well and what could be better, and document these for the next meeting with the planning department. Develop sustainable procedures. Then the next one, implement maintenance planning and scheduling. The next phase 6 is sustainability. Now, what do we mean by sustain? It is considered evergreen as processes and procedures should always be improving. So, be sure you have all performance metrics in place and review them in meetings, verifying that they are meeting long time trends. So, every aspect of the production activity should be documented. So, first thing is, how do we do all this? Clearly defined procedures or plans for each technician performing the certain task. So, we should have clearly defined plans for each of the processes. Second one, ensure new technicians are properly trained on these job plans. Third one is standardized, up to date and easily documentation in place. So, we should have proper documentation of all the activities done in the production house. A set time for conducting processes reviews to assess what is working and what isn't. This is also the time to go over how processes can be improved. Then, equipment reliability. The next part is equipment reliability. The term equipment reliability and maintenance, also called as the ERM, encompasses not only equipment such as machines, tools and fixtures, but also the technical, operational and management activities ranging from equipment specification to daily operation and maintenance required to sustain the performance of manufacturing equipment throughout its useful life. So, reliability is a special attribute that describes the dependability of the component. So, reliability means you are trusting the component. So, it means that component consistently performs a desired function under customer needs. Theoretically, reliability can be described as reliability is 1 minus the probability of failure. Next, ERM affects drastically three key elements of competitiveness: quality, cost and production and lead time. So, well-maintained machines hold tolerances better, help to reduce scrap and raise part consistency and quality. So, with the help of this ERM, we will be able to reduce the scrap and also raise the quality of the products which are being produced. By increasing uptime, the yields of good parts, it can reduce capital requirements, thereby cutting total production cost. It can also shorten lead times by reducing downtime needed for retooling. So, when we have a proper ERM in place, it will help in reduction of the production cost and also in reducing the lead time of production. The replacement and displacement of conventional electromechanical factory equipment by mechatronic equipment have given rise to a very different set of reliability and maintenance requirements. The recent rush to embrace computer integrated manufacturing has further increased the use of relatively unknown and untested technology. Now with the help of the computer integrated manufacturing, we are further increasing the use of unknown and untested technology. The factory is becoming a web of interdependent subsystems interconnected by computer controllers that communicate horizontally across peer processes and vertically to supervisory controllers above or the slaves below. So, with the help of this CIM, that is the computer integrated machinery, we are able to communicate everything horizontally, and vertical communication also is possible. Then, much of the controller software was written with the assumption that all equipment works properly, when in fact complicated and unpredictable failure modes and unanticipated by the system and equipment designers are becoming increasingly apparent. So, it is seldom possible to predict how a system will fail when something somewhere in the plant breaks down. So, because casual relationships are frequently hidden, repair is often time consuming, expensive and tedious. A better job of debugging these systems via simulation, analysis and rapid development needs to be done. So whatever with the help of the software, so we will be able to ensure that the production goes around without any breakdown. But somehow it is sometimes the system breaks down because of any one of the fault in any one of the parts. Then the next, methods to ensure reliability of equipment. So how can we ensure that there is reliability of equipment? So here let us see here. Besides the engineering practices described above, there are three other essential components to equipment reliability. One is maintenance, second one is inspection, and third one is technology. So there are three aspects here. First one is the maintenance. Maintenance can be divided into three categories, that is preventive, predictive and corrective maintenance. So in the preventive maintenance, measures are taken to eliminate unnecessary inspection and the repair task. So we should ensure that there is no unnecessary inspection and repair. Predictive maintenance generally involves non-destructive inspection techniques to monitor the serviceability of the equipment. So in predictive, we will be monitoring the services of each and every equipment. Corrective maintenance involves repairing or replacing components to restore equipment back to its operating conditions. So if there is any fault in any of the parts, so just replace that part. Collectively, they should be managed in a well-developed, reliability-centered maintenance program. Then, second one is inspection. So, non-destructive testing (NDT) techniques are used extensively throughout the life cycle of the equipment to locate and monitor damage the mechanisms. So, furthermore, it plays a major role in any equipment reliability program. Some common NDT methods used in petroleum and chemical industries include radiographic testing, ultrasonic testing, electromagnetic testing and many more. So, with the help of this radiographic testing, ultrasonic testing and electromagnetic testing, we will be able to see what is wrong with the machine. When selecting an NDT method, several considerations should be taken into account, including the type of damage, where the damage is located, and the size, shape, and orientation of the damage. So, where the damage is and how it can be rectified. Additionally, there are two other types of inspection that provide information on reliability and remaining life of the equipment. It includes risk-based inspection and fitness for service assessments. Put simply, the purpose of RBI is to identify and understand the risk in order to reduce uncertainty about the condition of the equipment. So, with the help of this risk-based inspection, we will be able to understand the risk and reduce uncertainty about that particular equipment. Fitness for service assessments are performed to determine if the component is suitable for continued service. So, with this, we come to the end of this session. Hope you have all followed it. Thank you.